We'll go over the quiz towards the end of class. We'll spend some time, extra time on that because we'll need some time for corrections. If you look on Hack, I just did it this morning, so sorry for the delay on it. Some of y'all probably appreciate it when you look at the grade. But I separated it into two columns. One is the unit circle itself, the first thing you did, and then the second one is the quiz itself. When you finished it off, I made them a weight of 50% each, so they average together. But the average of the unit circle was like a 97. That was awesome. The average of the quiz itself was a 41. That's pretty bad. For this class only. Yeah, so it's rough. So that's why today I want to spend a few minutes towards the end of the class. We'll be fine, don't worry. We'll spend some time at the end of class to do some corrections, okay? Because we're going to need it. All right, so it starts off with saying let t be a real number and let p equal this point on a unit circle that corresponds to t. T represents the angle, okay? T represents the angle. Goes on to say find the sine of t, the cosine of t, tangent, cosecant, secant, and cotangent. So we're going to find all 6 trig functions. Now, we have discussed really about the unit circle, talking about the x and y values. We've only discussed sine, cosine, and tangent. So the last 3 we'll go to and talk about that in just a minute. But for now, let's go ahead. Sine deals with what values? Y values. So, right off the bat, the sine of t is equal to the y value of the coordinate, which is root 3 over 2. It's a very bad looking one, but it works. Then we go on to say cosine of t. Cosine deals with what values? X values, so it's going to be negative 1/2. And then we finished off with tangent, which we kind of only briefly talked about. We haven't really gotten into much detail, but tangent's going to always be broken down as sine t over cosine t, or we can say y over x. And then with that, we go ahead and take the y value of our coordinates over the x value of our coordinates. So, of course, when you divide with fractions, you keep, change, flip. Like that. 2's cross out because they're cross-canceling each other, and you're left with negative root 3 over 1 or negative root 3. So then we go on to talk about what about the other 3 trig functions? Well, when we discussed those early on, we said, hey, comparison from sine to cosecant. Sine to cosecant is basically what, guys? The reciprocal of it. We flip it, right? So we can go on and take the answer of sine and flip the fraction. So cosecant of t is equal to 2 over root 3. Well, as we discussed before, you can't leave a square root as a denominator, so we're going to do what's called rationalizing it. You multiply the top and bottom by the square root that you need to get rid of. And so you end up with 2 root 3 over the square root of 9, because it's 3 times 3, which is 9. And do we know what the square root of 9 is? 3. So basically the cosecant part just flip it over. Now it's a little extra work because now you have a square root on the bottom, but it's doable. Now we go on and talk about secant. Secant is going to be a little bit easier, guys. Because secant is the reciprocal or the flip of cosine. Well, cosine is negative 1 over 2, so what's going to be the reciprocal of that? Negative 2 over 1. Or, like I said, it's a little bit easier since there's not a square root anywhere. So there's no rationalizing that has to be done. You just say, oh, negative 2 over 1, that's just 2. Yes, sir.
Tangent?
Mm-hmm.
When you did change flip,
Mm-hmm.
like, how did you get negative 2 over 1 equal to root 3 over 1?
Because the 2's cancel. Do you see? I'm multiplying it.
Oh, the 2's cancel out.
Yeah, so it's like this. And so you have root 3 over 2 times 2 over 1. The 2's cancel out, and so you're left with negative root 3 over 1. All right, now cotangent. Here's a little bit tricky because I did this step by step for this purpose only, is here. All right, cotangent, we're going to follow the pattern that we've been doing, which means takes the reciprocal of its opposite. So I come over to this spot here. Bless you. I don't want to take the reciprocal of this, because that's a lot of work that's going to be done. So what we did here was, hey, we did the divide, and we ended up with this one here, and then we simplified. So what I'm going to do is I'm going to go and take the reciprocal of that, which is already divided, which is perfectly fine. You can do that. So we'll take the reciprocal of negative root 3 over 1, which is negative 1 over root 3. And of course, we have to rationalize. I guess we'll do it step by step again. Well, I'm skipping one step. Square root of 9 is 3 again, so you end up with 3. So today what we're talking about is adding inverse trig functions. So if I was to go back and look at y'all's quiz, the very back page where you're asked to find the sine of 3 pi over 2 or the cosine of 5 pi over 6, if I was to just take those results, I bet the average in this class would be somewhere around an 87 to 90. Most of you guys really got it nailed down, okay? Which is great, because it gets into this. So it takes that and goes even further. So we're going to go ahead. As you can see here, we have a couple inverse trig functions. Normal functions like we talked about already before on this one, bless you, and so we'll do that. So let's go ahead and write those steps down that we've been doing, which is the first one is find the reference angle. So we're going to do the cotangent, okay? And so this is how I have always told my students, and it seems to work pretty well. So first thing you're going to do is you're going to go ahead and write out its inverse trig function. So the inverse of cotangent is tangent of 4 pi over 3. And now we go to finding the reference angle. So what's the reference angle of 4 pi over 3, guys? Pi over 3. Good. So we go through and say, okay, if you use the square root trick or if you use the hand trick. Well, if we have the hand trick, 45/60 is this finger here. For tangent, you have to flip it over. For tangent, you have to flip it over because it's sine over cosine. So it's the square root of 3 over the square root of 1. And I'm going to write it just like that. You took the inverse, reference angle, find the value, and now you go back up. Okay? So the value of this is here. What is the value of 4 pi over 3? So I need to ask you the question, what quadrant is 4 pi over 3? Second quadrant. Because what are you doing with number 3 to get to 4? Adding 1, so what's that going to be? Third quadrant. Third quadrant. In the third quadrant, well, y is what? What's x? So what's a negative divided by a negative? Positive. So it ends up being positive. And I write it again. except I'll just say 1 because it's kind of reducing it. I am rewriting the answer. Because if it's negative, guys, I wish I would have made this bigger, sorry. But if it's negative, it'd be negative root 3 over 1. And then finally we do the last step, which is flip it. And then rationalize. So it kind of makes a U. Here, take the inverse, reference angle, find the value, find its sign, then flip it. You know, it's like 6 steps, but they all kind of just go, and it's little step at a time. Little bitty steps. Inverse, which means just find the opposite cotangent. Oh, that's tangent. Find the reference angle. That's pi over 3. There's pi over 3. Now you have to find the value. That's where the square root trick comes in. Then you come up and find the sign. What quadrant am I in? What sign is it? And then finally, I flip the answer to get what I need for inverse. Now that's the only steps you have to do, guys, when we're doing inverse functions. So if we come over to tangents, well, there's nothing of this step here. You just go straight to there. What's the reference angle? Then what's the sign? And then there's your answer. So we have one extra step we add when we do the inverse. So let's do one more inverse. Let's go over to this one, the secant of 5 pi over 6. Great. I'm going to have to scroll up. So, again, find its inverse. The inverse of secant is cosine. So the inverse of secant is cosine. Inverse. Then the next step is reference angle. Yeah, sorry, 5 looks pretty bad. You good? Okay. So reference angle is pi over 6. So the cosine, so it's actually 30 degrees. So we're here. Cosine is going to be square root of 3 over 2. And then we find out what quadrant are we in. Second quadrant. Second quadrant. Cosine is what values? X values. In the second quadrant, X values are negative. And then we finish it off by the last step, which is flipping it. Nope, it looks like it should be, but it's not. Sine, opposite is cosecant. It is weird. It's backwards, I know. I agree. Wait, what'd I do? What am I doing? There you go. So, and it's negative, sorry. 2 root 3 over 3. So again, you're just kind of following the whole inverse, find the value, and then come back up. Makes a big U there.
Are they all going to be over 3?
No, it seems like they will, but sometimes it'll be over 1 or, yeah.
That's what I was asking you.
Yeah, no, they're going to be, no, they'll be mixed up. But yeah, it just so happens they all are over 3 right now. Because like when it's 1/2, the flip of that's going to be 2.
Yeah.
So, all right, let's go on to tangent of 0, the one we kind of skipped. So tangent of 0, well, let's go through our steps. What's the reference angle of 0? 0. Tangent, we always have to do something a little bit different. So for me, I could always say, okay, tangent. Of course, I always use the hand trick because I don't want to write the square root out for that. But so for, you know what? Let me help you guys out. I know a lot of you guys use the square root, and I'll just go ahead and write it up here so we can refer to it. Bless you. All right, there we go. No, probably y'all can't see that very well over there, but sorry, I'm going to write it twice. So with that over there, we're looking at the tangent of 0. So the reference angle is 0. So we're here. Remember, tangent's going to be the sine over cosine. So it's going to be the square root of 0 over the square root of 4. And so we'll go ahead and write that. Just like that, too. We simplified a little bit, which we really don't need to very much because we noticed that 0's on top. What does the answer mean if 0's on top? It's just 0, right? It's just 0, and there's your answer. We're done. So without the reciprocal function, as you can see, we still find the reference angle. We find its value. Well, in this case, and then supposedly find its sine, but since the answer is 0, do we need to find the sine? No, so that's skipped. That step is skipped now. All right, so negative 3 pi over 2. Great. So negative 3 pi over 2, we go ahead and find a reference angle. And we say, okay, pi over 2 is here. Cosine is square root of 0 over 2. Which actually just ends up being 0, right? I mean, to be honest with you guys, the more and more I use the square root, I do kind of like it more and more, but unfortunately you still have to write it out every time. That's the part I'm not a big fan of. So that's the only thing is. Hand trick's nice because just look down your hand, turn in the finger you need, and from there you're done. That one takes some time to write out. All right, so we've already done cotangent. Let's go over to sine of 8 pi over 3. Reference angle. Pi over 3. So what is the sine of pi over 3?
Root 3 over 3. So like, you know how the denominator is squared 8? What is that?
So we're going to get to that. So the deal is it's 8 pi over 3. Well, let's go through our little tricks we've had, figuring out what quadrant we're in. D minus 1, D plus 1, 2D minus 1. Well, that's not the case right now, is it? We've got, what? It looks like it's times 3 minus 1. Would you agree with that? So the deal is we're looking at, and this is what some of you guys got really troubled with on the quiz. This is a coterminal angle, which means this angle right here, guys, even though it's in radians, has gone around a circle completely once. So let's start counting it out. How many pi is that? 1 pi. 2, 3. I'm going to stop right there for a second, okay? So what we got to do is figure out, well, this is in fraction form. It's not in whole form. So if we were counting by pi, which means if it was not in fraction form, it'd be 1 pi, 2 pi, 3 pi, 4 pi. 4 pi means we went around twice. Okay? So what we kind of do is, guys, I would probably recommend reducing that down. Put the pi aside for a moment and look at 8 over 3. Okay? Look at 8 over 3. What does that reduce down to? What does 8/3 reduce down to? How many times does 3 go into 8? Twice. What's left over? 2 2/3, right? So what that tells you is 8 pi over 3 is actually 2 pi and 2/3 pi. 8 pi over 3 reduced to 2 pi and 2/3 pi. Well, what is one full circle around, guys? 2 pi. So I can go ahead and eliminate this 2 pi because, guys, in a circle, what happens if I go completely around it? Where do I end up? Right where you started. Right? Some people have used I've heard it a few times too, I even heard it on news, it's pretty funny. Some people have turned their lives 360, like, they try to say they turned their lives around. You know, they're doing bad, selling drugs, getting into trouble all the time. Now they've done their life and changed it, did a 360 in their life. I'm like, they're in the same direction. Should be 180, right? Right? If you do 180, don't you go the opposite direction? If I turn it 180 degrees, don't I go that way? If I do 360, I'm back where I was looking to begin with, right? I thought it was interesting. An anchor person says, like, you just said that wrong. They're going the same direction. They're still bad. So we're left with 2/3, which, if we put pi back in, it's 2 pi over 3. So now, what quadrant is 2 pi over 3? Where are you at? Yes, say it. No, what you said first. 2. 2 pi over 3. What do I do with 3 to get 2? Subtract 1. So we're actually in the second quadrant, aren't we? We're in the second quadrant, and sine is what values? Y values. And the y values in the second quadrant are positive. So be careful with it. It's going to happen. There's going to be questions where it's going to be around the circle once. So you've got to reduce it. Take out the 2 pi when it's in radians. Take out 360 degrees if it's in degrees. It'll be easier when it's degrees, I know, because you're just subtracting two numbers. It's a little bit harder when you're looking at radians because you have to subtract 2 pi from a fraction. Okay? But use the trick I said over there. Go off to the side. Write the fraction without the pi and reduce it like you've done in math for a long time, right? Any 2 pi goes off. Okay? All right. Tangent. Let's move on to the next one. Tangent of 7 pi over 6. First step is what, guys? Sweet. You are listening. What is a tangent of pi over 6? We'll get to fixing it later. What quadrant are we in? Third quadrant? Why, Hayden? There you go. Because 6 plus 1 puts us right there. Third quadrant. Third quadrant. Tangent, you got to think about both sides, don't you? You got to think about sine and cosine, guys, because remember, tangent is sine divided by cosine. So you got to think about both of them. Both sides in the third quadrant, let me just ask you this. Are both sides the same or are they opposite? Why do you think I'm asking you if they're the same or they're opposite? When you divide and multiply with signs that are the same, what's always your answer? Positive. When you multiply or divide with signs that are opposite, what's always your answer?
Negative.
Y'all see that? Yes. So that's why you just asked the question, are the signs the same or the opposite? Because guys, I'll tell you, tangent is going to be positive in what 2 quadrants? First and third. Because first and third, the signs of x and y are all the same. Tangent will be negative in what other 2 quadrants?
2 and 4.
2 and 4, because the signs are always opposite in those quadrants. So just ask the question, guys, when you're finding out the sign of your answer with tangent, just ask, are the signs same or different in that quadrant? Just ask that one question. All right, so we decided that they're the same, so that means your answer is going to be positive. So we reduce or simplify, whatever, and rationalize. Bless you. Oh. Kayla, God blessed you. Okay. There you go. All right. Inverse function for cosecant. What is the inverse of cosecant? What is the reference angle of 300? Not as easy with when it's not in radians, unfortunately, but what is the reference angle of 300? 60. How many degrees does it take for me to get back to the x-axis? 360. Okay. All right, so with that, we go ahead now. What is the sine of 60 degrees? Going back up, 300 degrees is in what quadrant? Fourth. And sine deals with what values? So therefore, it's negative. We are talking about cosecant. And then now rationalize, right? Guys, I don't know if y'all noticed it after a while. I've done this many times. A simple way of rationalizing it, and I don't know if it'd be simple for you or not. Basically what you're doing is you're taking the square root of 3 and you're moving it to the top. Okay? Then you take what's in the square root and copy it down to the bottom. So I'm going to take the square root of 3 and move it to the top. Then I take what's in the square root, which is 3 for this particular problem, and just write it below. And that's what you do every single time. All right, last one. Tangent of 90. We'll go through the steps, even though we don't really need to on this one, but we'll just go through it. What's the reference angle of 90? 90. What is the tangent of 90? Root 4 over root 0, or 2 over 0, which is undefined. But does not exist, no solution, undefined, whatever you want to write there, no answer. All right, so just kind of a little review there of some trig functions again. Moving on. All right. And this will be the last two things we have to do for our notes, and we'll be done. So, this one says name the quadrant that this particular values are in. So these, all this basically is asking you is it positive or negative, or what quadrant you're in. So you just got to figure out, well, what values are we talking about? X or Y values, is it positive or negative? So secant, what is the inverse of secant again? Cosine deals with what values? X. And it's saying that x is below 0, which is another way of saying that x is negative. Tangent is y over x, which needs to be greater than 0, which tells you what? Positive, which both signs are the same. Where is both signs? It's either positive, positive, or they are negative, negative. Right. It's in the third quadrant because both signs are the same. And where are both signs the same when we're talking about the unit circle, guys? When we're talking about the coordinate plane. Here and here. So the fact that tangent is positive tells you you're in the first or third. Then you go on to look at the other one and say, well, secant is negative, which means x is negative. So then you solidify that it is really in just the third quadrant. Or you can go in order. Where is x negative, guys? Second quadrant. So with just the first thing, secant saying negative x, secant being negative means x values are negative. You're in the second or third quadrant, and then it goes on to say tangent is positive, which means both signs are the same. So you go, second or third quadrant is both signs the same. and it tells you again it's there. We have to give you two trig function values, guys. Because if we give you one, you can narrow it down to two different quadrants. There is not one trig function, if you know it's positive or negative, that will tell you exactly what quadrant you're in. Just because every combination of x being positive, y being positive, and vice versa, and both being the same or the opposite, gives you always narrowed down just to two. They exist all different combinations. So as you can see here, guys, you'll step through and say, okay, what values are you asking me for when you say secants? That's x values, and it's less than 0, which means it's negative. Then you moved over to tangent. Well, we know tangent is positive when signs are alike. That tells us it's the third quadrant. Okay? So now let's look at number 4. 4 is a reverse of the problem that a bunch of you guys really struggled with on the quiz. And we did the problem on the quiz because, guys, when I made the quiz, I copied straight from the notes the problem onto the quiz. And it's where it gave you the coordinates 4, 3, or 3, 4, and asked you to find the value of all the trig functions. Okay? All I did from form A to form B is flip it from 4 to 3 and 3 to 4. So I want to make the level exactly the same. So some of you guys had the x value as 4 and y value as 3, or vice versa. And I had to help some of you guys through that, which I shouldn't, but I got a soft heart, I guess. So we did that on the problem, and so we said, okay, 4, 3, let's say. The point is 4, 3 on the coordinate plane. 1, 2, 3, 4. 1, 2, 3, which means I am located right there. Then I asked you guys to go ahead and write the coordinates out. So you did this. And then I said, write a line from that point directly to the origin. You did that. And I said, write a line straight down to the x-axis and stop. And you did this. And from there you guys go, oh wait, this is a triangle with this leg 4, this leg 3, this leg 5. And then you're able to go ahead and find all the trig functions from there, right? Because you could either use SOHCAHTOA if you wanted to, or you could use what we just learned, which is x over r, y over r, y over x. Remember, cosine is x value. So cosine is x over r. Well, when we're talking about the unit circle, guys, when we started this, the unit circle, the radius r is 1. That's why it's called a unit circle. So all we did when we talked about the unit circle, guys, values, we just said, what's the x value? But when we're looking at this one here, this is going to have different values. This hypotenuse is 5. So then you're looking, okay, so the cosine of this, guys, is going to be 4/5. The sine is 3/5. Tangent is y over x, so 3/4. And then right next to it, you just had to find its inverse, which means just flip the answer you had, right? It's pretty bad. Some of y'all struggled with that one. And those were 4 points each question. So it ended up being 24 points off if you didn't get it. That's just the way the cards lie. All right, so I'm going to erase all this because I just wanted to show you that. And so this one goes on to say, given that the tangent of theta, well, I'm going to draw theta. Remember, guys, this is how I told you about how we do standard position. You start with the positive x-axis. You go counterclockwise. There's theta. It says, given that the tangent of theta is 3/4. Well, tangent is what over what again, guys? Y over x. So we could easily write, or you guys learned in geometry, TOA. O over A. You need to go back that far. So then you see this, you say, okay, it goes on to say, well, this is a 3, 4, 5 triangle. It says, find the sine of theta. Sine is what over what, guys? Go ahead, say it. Y over r. That's great. Y over r is right. Or just the y value would be good enough for me. So what is the y value here, guys? How far did we go up? R is your hypotenuse. So what's the hypotenuse of this triangle? So just like what we've done, we said, okay, find the angle. We're going to find its pieces to finish it off. Then we went ahead and used sine. And now always the one question is, before you get done, is it a positive or negative answer? Is it a positive or negative answer? Well, let's see. This goes on to say, what here? Cosine is less than 0, which means cosine is negative, which means what values are negative? X. Which means that is negative, guys. Okay? What do you notice about the value of tangent? It's positive, which tells you what? They're the same. You see that? Knowing the fact that tangent is positive and knowing that they're the same values will help a lot. Helps a lot. Okay? So basically, guys, it's the idea of transferring your thoughts of sine and cosine is now x and y. Once you start seeing those connections, these problems get a little bit easier and easier as life goes on. Okay? If you're to see that right off the bat, tangent, oh, that's y over x, which is 3 over 4. The y value is 3. The x value is 4. So I draw a little triangle, give me my hypotenuse, because they're asking for the sine. In order to get sine, you have to know the hypotenuse. So that's why I drew the triangle there, to get the hypotenuse. Then from there, we're like, okay, well, the y value was given to me already in the problem. Remember, sine is y, right? It's given to me in the problem. It's y over x, or 3 over 4, or the y value is 3. 3 over the hypotenuse, which is now 5. We figured that because we did a triangle. And then the last part is, well, is it positive or negative? Well, if you notice, guys, all the work we did right before we got to positive and negative never even dealt with that at all. We didn't touch that until the very end when we were looking for the sine, right? All I looked at was tangent and sine to get my answer. And then I had to deal with it, is it positive or negative? Well, that's where cosine theta less than 0 came into play. Because that's telling us the x value is negative, which we did there. And you guys know by now, tangent, if tangent's positive, that means the signs are alike. Right, Connor? Good. So that's the reason why y is negative. That concludes our fun for today, guys. I know you're thrilled.